All right, so the first thing we did was we wrote the chemical formula for carbon tetrachloride. Sure enough, 1 carbon, 4 Cls. To get a Lewis dot structure, we have to know how many dots we have. So, number 9. Sawyer, how many dots does this molecule have? How many dots for a carbon?
4.
Yep. And how many for each Cl?
7.
Yeah, 7 times 4, 28. All right, 4 plus 28?
32.
Yep, 32 valence electrons. All right, where do we want to go from there? Number 11, Alex.
We're going to start setting up your
Yep, and how do we do that?
put a carbon in the center, a single bond to each.
Yep. Sound good? So at this point, we've used up 2, 4, 6, 8 electrons. So we've got, what, 24 more to go? All right, where am I going to put those 24 electrons? Nick?
Would you draw, like, make it 3D and make it...
We're eventually getting to that point, but before we do that, we have to have a Lewis dot structure. So is chlorine happy with 1 bond?
No.
No, it needs some more dots, right? How many more dots would it need to get to the octet? 2?
Yep.
4? 6? 8? So it needs 3 lone pairs? Okay, same thing here. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. We have 8, 8, 8, 8. So, Nick, what's 8 times 4? 32. There you go. Sure enough, we have the right number of dots. Does everyone have an octet up there? Yeah, we're good. How do we know if this is the best picture possible? 21, Seth. Is that a good picture?
Yeah.
All right, prove it to me. How many bonds does carbon usually like to form? 4. Does it have 4?
Yep.
Yeah, we could go through the formal charge if you really want to and say carbon should own 4 electrons. It owns 1, 2, 3, 4 out of the 8. So yeah, it's going to be 0. But if carbon has 4 bonds, it's going to be a formal charge of 0. And how many bonds does chlorine like to form? Usually, Livy. Yeah, it's in column 17. How do you get to column 18? You form 1 bond. So the fact that it has 1 bond makes me think it's good. If you really want to show the work for the formal charge, it would be 7 minus 1, 2, 3, 4, 5, 6, 7. So sure enough, formal charges are good. What would be the domain formula? Number 18, Cody. I'll get you started. Carbon would be the central atom A. What's connected to the central atom? 4 chlorines, and that we don't really care what atom it is, so we just label it as X. So AX4.
Yeah.
Any lone pairs on that central atom carbon? Any E's? Any dots on the carbon? Nope. So it's just AX4. Does that make sense? Now, why do we care about that? That's 4 things attached to the central atom. What would be the basic domain shape for that? Question? Nope, we're good. Okay. Colino, basic shape for 4. Tetrahedral, yep. I'm going to go ahead and draw it. Kind of looks like that camera tripod. Here's the deal. The molecular shape will only be the same as the domain shape if they're all X's. Well, hey, they're all X's. So therefore, I don't have to cover up any of my balloons. So therefore, it's going to be the same exact shape. So tetrahedral, tetrahedral. Now, let's say one of these was an E. Well, then you cover it up. What's left? If it would be AX3E, then you would say the molecular shape looks like a what? Yeah, that looks like a triangle pyramid to me, right? and let's say there'd be 2 X's and 2 E's, cover up 2 of the X's. So the domain shape was tetrahedral, but if it's AX2, E2, that would look like what? Bent, yeah. So that's why we do the domain formula, so that you only have to memorize 5 shapes, you cover things up, and then get the last one. But you don't need to cover up any balloons or domains if they're all X's. What would be the perfect bond angle for a tetrahedral? Number 12, Kalina. Bond angle? That would be if a circle was broken up 3 ways. This is 3-dimensional space broken up into 4 equal angles. Okay, yeah, this looks like a 90 over here. That looks like it's more than 90. There we go. Tetrahedral's 109.5. Radio stations don't go up that high, but if they did, that's the one I'd be listening to. 109.5. All right, finally, does our picture over here, the original picture, look like a tetrahedral? Oh, you got to redraw it. So, carbon, chlorine, chlorine, going off into the sunset, chlorine coming out at you. Whoa, chlorine. And oftentimes when you redraw it, you wouldn't have to draw all the dots unless it specifically says that. But yeah, I have a molecule that looks like a tetrahedral shape. Questions how we did that? So at the beginning, you might have to be using your graphic organizer to check, but as soon as you can, just start putting it off to the side, using kind of what you see on the board, try to answer it. Then if you have to go take a sneak peek at what the X's and E's are, that's fine. But eventually, as you get down towards the bottom of the activity, see if you can do it just by looking at the 5 basic shapes without actually looking at the graphic organizer. Any questions on that?